So for the final little piece here that we're going to talk about in this particular video, we're going to start trying to form a specific type of proof. But before we do that, we need to understand what the word included means. So when we're talking about an included angle or side, we're talking about something that's in between two other things. So angle A, which is right here, is included between AB, or BA, and AC. It's in between those two things. Whereas if we're talking about a segment, if we're talking about segment BC, this is included between angle B and angle C. So included means in between. So let's practice a little bit here. If we're looking at segment AB and CA, what angle is in the middle? Angle A. If we're talking about angles A and C, what segment is in between them or included? AC. If we're talking about BC and AC, we're talking about angle C. And so on and so forth. Go ahead and try the next three on your own, then unpause to check. So between B and C would be BC. Between BC and AB would be angle B. And between B and A would be BA or AB. So now, why does that matter? Why have we spent this time talking about the word included and what that means? Well, the next section of your notes is going to be about proving that two triangles are congruent in the quickest way possible. So it's going to give you two different figures of triangles, and it's going to say, do you know if these are congruent using one of the 5 shortcuts? So the next slide is super, super important. You're going to want to pause and write down what's on the screen and then come back to hear what I'm saying. So again, pause here, jot this down, and then unpause to hear me talk through it. So the first shortcut of triangle congruence says all 3 pairs of corresponding sides are congruent. So if we've got 2 triangles where we have 1 pair of corresponding sides, 2 pairs of corresponding sides, and 3 pairs of corresponding sides congruent, I know for a fact that those are identical or congruent triangles. The next shortcut says I have 2 pairs of corresponding sides congruent and 1 pair of included corresponding angles. So I can draw any types of triangles I want. I can make them look the same as before, it doesn't matter. I'm going to mark 2 pairs of corresponding sides. And then I'm going to mark the angle in between them, or included, as congruent. So that now I have 2 sides and the angle in between. So notice, side angle side has that sandwiching effect. That's how we know it's an included angle. So we have 2 sides and an angle in between. So for the next one, we have the same sort of setup. We have the side in between 2 angles. So when we draw our 2 triangles again, you can make them look like whatever you want. We want to mark 2 pairs of corresponding congruent angles and 1 pair of included corresponding sides. So the side in between those 2 angles has to be marked congruent to the side in between those 2 angles. Now for the next one, we do not have that sandwiching effect. We have 2 angles and a separate side. So we're going to draw any 2 triangles we want. We're going to mark 2 pairs of corresponding angles. And then we're going to pick one of the non-included sides. So I might pick the one beside the single marking and the empty angle, if you will. So in the other picture, I'm going to pick the single and the empty for my marking. So it could have gone right there, or I could have put my markings between the double and the empty angle, and the double and the empty angle. Either way, we have two angles and a separate side. The last option that we have here is called HL, and we're using different letters here, so that should trigger us that something's a little bit different. So HL stands for hypotenuse leg, and hypotenuse means that we have to have a right triangle. So this trick only works for right triangles, but that doesn't mean that every pair of right triangles are going to be congruent. It still has to meet the criteria. So I'm going to start with two right triangles. Again, doesn't matter what they look like as long as you've got your right angles. The hypotenuses have to be congruent. So remember that the hypotenuse is across from the right angle. You can think of that right angle as an arrow. So this is my hypotenuse here. And across from this guy, my hypotenuse is here. So the hypotenuses, which I know sounds like a funky word, but that is the plural of hypotenuse. Our hypotenuse has to be marked congruent to the other one. And one of the pairs of legs, so one of the other sides, it does not matter which one. So one of the other pairs of sides has to be marked congruent for HL. Now guys, if you notice, 4 of these tricks involve the letters A and S in 3-letter combinations. So you'll notice there's a couple up here that are not listed, right? Angle, angle, angle is not listed. I would encourage you to think about why that wouldn't work. We'll talk about that here in a minute. And angle, side, side is not one of our shortcuts either, and it's not just because it spells an inappropriate word. There is a mathematical reason for that. So if you search, why is angle, side, side not a valid method of congruence, there's a lot of great videos that demonstrate that. So now, let's put this into practice. State if the two triangles are congruent. If they are, tell me how you know. So for the first picture, I see that all 3 pairs of sides are marked congruent. So yes, these are congruent by side, side, side congruence. And again, the equal sign with the squiggle above it just means congruence, same shape, same side. Number 2, I notice that those 2 triangles share this side down the middle. So if they share that side, if I were to separate these 2 triangles, I'd have something that looks like this, where I know for a fact that this side is the same as this one because they came from the same segment. So you'll notice down here we have markings that we can add to our picture. So we can add a shared side or a reflexive side, right? We said that was going to have a purpose. Here it is. So now, if I look at the pictures, I've got 2 corresponding pairs of angles and a separate side. It's not the side between them. So we have angle, angle, side congruence. Now number 3, we have vertical angles here. So I can add that to my picture. That's the second thing we can add so far. If I look, I have 3 pairs of angles. So angle, angle, angle is not one of my 5 shortcuts. So even though I can add a marking here, there is not enough information to know if these are congruent. Here's kind of a good representation of why. This might actually look like this, and I'm going to try to draw that a little better. So there's not enough info. Make this one really large and this one really small, right? So we could have congruent angles here, here, and here. However, that doesn't tell you anything about the size. So if one of them could be smaller than the other, they're not congruent anymore. So that's not one of our shortcuts. I would recommend you try 5 through 8 on your own, then come back and check. Again, we have that shared side here, that reflexive property, so we're going to add a marking here. We have two pairs of angles and the side in between, so angle, side, angle, congruence. Number 6, we can add our vertical angles here. So we have two pairs of angles and not the side in between the two. So if you look, the side between the two angles is not marked here. The side between the two angles is not marked here. So this is two angles and a separate side, not the side in between. Number 7, we have a shared side here again, so we can add a marking. This is a right triangle, so I could use HL, or I could still use any of the other 4 postulates or theorems. So, if I look, the hypotenuse is marked in both pictures, and one of the legs is marked. So this is a case of HL congruence. Number 8, two angles and the side in between, so angle, side, angle. The last little bit here, we're going to say what additional information do we need? What's missing? Now remember, we can already add shared sides, vertical angles, and we're going to talk tomorrow and on throughout this module about the parallel line postulates. We haven't used those yet because I don't want to throw too much at you at once. So looking at number 11, I know I can add that anyway. I know that I have vertical angles there. What they want me to use is angle, angle, side. So they want to know what other information would you need to make that happen. Well, I would need this angle to be congruent to this one. So I would need angle W to be congruent to angle S. Sorry about that interruption, guys. We had an announcement. So for the next one, we need side, side, side congruence. So looking at what information we currently have, we already know QP is congruent to PL. We already have a shared side here, so we already know that. They don't have to tell me that. That's something I know. So for side, 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 what's missing is that QR is not marked congruent to RL. So they would need to tell me that those two things are congruent. Number 13, we have another shared side here. Since they've started with a double marking, I can use a single if I like, or a triple, doesn't matter. They need me to use side, angle, side. So I need the angle between these two sides. So I need this angle right here to be between those two sides. So that's angle GIJ. Needs to be congruent to the angle right here between those two marked sides. So that's angle IJ. For the last one, we need angle, side, angle, so we're missing this side in between the two marked angles. So DC would have to be congruent to KL. At this point, guys, you've made it through the video for today. Go ahead and proceed to the practice questions.